Hey everyone, a couple of minutes late, but we will get started now after everyone has joined. Thanks very much for joining. Let everyone join. So we are joined by two customers and our Oracle presenters today. So thanks very much everyone for joining. Thanks to the presenters. So as most of you know, this is part of the Global Leaders Programme. We have been around for lots of years and we try to support our customers implementing our data warehousing and especially just now our autonomous database products. We have our Cloud World event on the 20th of October. We have a registration page open now. I sent a link last week to register for that. I hope many of you are coming to that. It should be a great event, especially on the Thursday hour meeting. We will have our Global Leaders event in Miami in February. I will have a registration link soon for that. I hope you can come to that. You know, we do these meetings to help you be ready and have the latest information on our products. We are running an autonomous database strategic customer program for new customers that are implementing autonomous database. If you're doing so, get in touch with me and we will fill you in on that. We are also doing autonomous database and Lakehouse checkups, which a few of you have participated in. Again, we've ran our feedback session in May with our executive management. We will run one of them at Cloud World again on October 20th, and we'll have our next one in April. So to today, so this is one of our direct from developments, part of our avenue for sharing information and our updates. So it's great that we have Derek Hayden from Outfront presenting today with us, and Tony Velich, who actually is ex-Oracle from WANDisco, talking about their migration practices and products. So we're doing these events every quarter where we have, we're doing a broad range of topics across the data management infrastructure. So today we have Jamil, who will open up and give us an update on what we're seeing from data warehouse implementations. Then we have Massimo Castelli, who will cover our new industry architectures that we're rolling out and sharing with our field and with customers for best practices. We have Sinan, who will talk about our new DMSA solution with Azure and also our best practices for multi-cloud. Derek will talk about how he has progressed his Lakehouse architecture. And Peter will talk about data mesh, and then on to Tony, and then we'll finish up. So again, you are all on mute just now. You know, ask any questions in the chat or in the Q&A. Our next direct from development is in November. We'll have our ADB champions meetup in a couple of weeks, and then again every month. And the recordings are there on our Global Leaders webpage. So with that, I am going to pass over to Jamil, and then we'll go through the various speakers and, you know, ask any questions. So thanks very much for attending. And Jamil.
Can you stop sharing?
Yep.
Okay. Share my screen. Can you see my screen?
Yeah, I do. Architecture is going on. Very good. Thank you.
Today, I want to do something a little bit different. Today, from various speakers, you are going to hear about what is the right thing to do, how to implement these architectures, what products and services available, how we can help you in your implementation journey. While they're going to talk about what are the right things to do, I want to give some practical examples from real life what not to do, and some architectures that we have seen gone wrong, to give some understanding of what to avoid, to able to make successful implementations. So it will be very brief to set the stage for the other speakers. One of the things that I always tell to the customers when I talk to them is like, there is a difference between a drawing an architecture and actually implementing an architecture. So when I look at these architectures, when customers show me, or when I look at architectures from Oracle or other vendors, I immediately think about how to implement these architectures. Is this architecture going to be implementable? It is easy to draw a bunch of boxes and draw some arrows in between them, but it doesn't mean that you will be able to successfully implement these architectures. One of the critical things that you can think is it's easy to put a box and put an arrow to it, but is that box, is the product or service that you will put behind that box, is it going to be able to do the job for you? One of the examples I can give you for we have seen in the past is, for example, when the Hadoop came along, we start seeing people creating these architectures where they remove the relational database or the data warehouse and put the Hadoop in place for those things, thinking that they will be able to keep the same architecture and just replace the data warehouse with Hadoop. But soon they start on seeing that actually Hadoop cannot completely replace a data warehouse. You cannot just flip over and replace it with something. Hadoop has some stuff that it does good, but there's stuff it cannot do. So when you are drawing these architectures, when you're implementing them, you need to make sure that the products and services you are putting behind that architecture is actually capable of what you are looking for. Also, these arrows is easy to put an arrow between one box to the other, but it doesn't necessarily mean that the data will flow seamlessly, continuously between those boxes. Sometimes in those architectures, we see that arrow doesn't even exist. You have to go and implement them. Or that arrow is not a straight arrow. It has to go through a bunch of other hoops to be able to go from one box to the other box. So when you're looking at those things, you need to make sure that the arrow you are drawing in that architecture is actually implementable, or there's when you implement that, it will satisfy your needs. For example, there might be an integration available between one service to the other service, but it may not be doing everything. For example, it may move the data for you, but it may not provide data integrity for you that you have to go and implement yourself. So these kind of stuff you need to think about when you're looking at these architectures. Are these architecture diagrams actually implementable? Is the services and products support these things? Those things really exist. And it's the same thing for accessing the data as well. You can put an arrow saying that, oh, data comes from this system, go to that system. But generally, those raw data that is coming into your system, not always directly accessible. It needs some processing. So how are you going to do that processing? Is the tools and feature sets available in that product or service to be able to provide that processing? Or accessing to the data? For example, one customer in the early days of ADW showed us an architecture diagram where they show they put the ADW as their data store and their BI tool, and draw an arrow and saying that this is what we are implementing. And we told them, your BI tool doesn't support volatility, so this architecture is not going to work. That arrow doesn't exist. So luckily in their case, the vendor was very open, so they quickly added the feature functionality to be able to make it work. But the architecture diagram that they drew initially was not implementable, and they didn't realize that. Another thing is looking at the security of the whole environment. Like you can draw these lines and the arrows, but how is the security going to work out? Is those products and services going to have the security feature functionalities for you to be able to build this architecture in a secure manner? And I'm going to show you some examples how that can quickly deteriorate if you are not careful on implementing an architecture. Also, like sometimes people assume that things will always go right. The services will be always up, the data flow will be running continuously, and they don't think too much about what if something goes wrong? How am I going to handle? For example, you draw an arrow, moving data from one system to the other. What if somebody does a double load the same data twice? Is your system going to be able to handle that? The product that the data is flowing in going to be able to handle that? What if that data movement fails for some reason and you have to restart it? Is that data movement restartable? Is the products and feature you are using will let you restart it from where you left off, or it's going to require rebuilding everything? The sizing of the system is also important. You can have the best architecture in the world, but if you don't size it properly, you will again fail during the implementation. Another part of it is when you are looking at these architectures and looking at the cost of building these architectures, sometimes people look at too simplistic. Like they look at like one CPU is X dollars on that product and Y dollars on the other product. And they compare this, but they forget the implications of, for example, the cost of implementing the missing functionality, cost and the value that those products and services, added value that products and services bringing on the table. So, and they misjudge, like one product may look more expensive, but the benefits bring by that product may outweigh the other product, because when you go to the other product, you may have to spend much more money to be able to add those functionalities, implement these missing stuff on the other side. So those are some of the things you need to think about when you're looking at an architecture. Is it really implementable? Is the feature functionality is really there? And I understand that this can be sometimes overwhelming. There's a lot of products and services, and there are a lot of vendors out there. That's why today we are going to talk about by other speakers to guide you some examples and best practices that is implementable, that we know that those products and features, functionalities available to build those with Oracle products and services to be able to guide you to end up with successful implementations. And sometimes people say, these are common sense things. People don't make these mistakes as much. They are careful. They do due diligence when they're implementing these things. But you will be surprised when you look at these big companies, when you go and analyze their systems for various reasons. Sometimes it is lack of knowledge, sometimes politics, sometimes legacy, things getting carried over. They are not implemented properly. Things that you think that it is common sense, you will see things that it is completely against the common sense. I will give you some of examples for you to better understand what I'm talking about. For example, this is a retail company. When we went to their system, what we saw that they, over time, they implemented 3 separate inventory systems. So they implemented one inventory system for their retail stores, one for their warehouses, and one for their online stores. And they have these nice arrows in between, data moving back and forth between those systems. But in reality, what was happening is they were not able to keep them in sync. They had data quality issues. They were implemented with different technologies. They all had their own data quality issues. They were loaded with different frequencies. And at the end, what happened there is a simple question like, is a product available in the stock or not? They were struggling to answer. And in many cases, we have seen that in their online store, when they say something is out of stock, the product was actually available. And when we were talking to this customer, they were in the process of implementing a 4th system just to be able to bring all these things together. Not as a replacement, just to be able to make things align and about do analysis over this data. And when they start building that 4th system, they realize that situation is way worse than they thought. And the misalignment and out of sync situation is way worse than they thought. Another example is a finance company. When we went there for a health check, we saw that they showed us a nice architecture with like Exadata systems, ODI for ETL, OBIE for data access. So it's a nice architecture. Then we start looking at the system and we realize that during the day, there is no access to the system. The load in the system is like less than 5%, actually most of the time less than 1%. And when we start digging in, we realize that in the morning, there's a bunch of people coming in and running these select star from queries from these tables, including account tables, pulling all the data out. And when we realize where the data is going, we realize that a lot of people have their little databases under their desks. They were pulling all the data to their systems and accessing from there. So this nice, secure environment they built are actually bypassed, and nobody was using the system. And they are completely lost control of the data. They don't even know how many of these systems are out there. And when we were looking, we even realized that one of those systems is out of the country, which is against their data residency laws. And when we pointed out that this is a big risk, they freaked out. They said, please don't put this in the report because they will shut down the system immediately. So we work with them, but if you think about it, like they wasted a bunch of resources to build this nice architecture, but they end up with a situation like there's serious security risks. They don't know where the data is going, who is accessing it, how they are accessed. On top of that, they have a legal exposure now because of data residency law. So you may end up start with nice boxes and architecture, but things can get out of control very easily if you don't pay attention how it is being accessed. Another example is one company which has a lot of different systems and different teams. One of the teams decided to move their system to the cloud. And what they did is, as expected, they want to simplify the management, they want to lower the cost, they want to have a modern architecture. The problem is they didn't look who else is accessing this data, what are the dependency systems. And the moment they move the system to the cloud, bunch of on-prem systems starts failing, timing out, because they realize that there are some applications that has very low latency requirements. And since they didn't check, they break all these applications. And it takes time for them to be able to find a solution for that. And their solution was to create a local copy of that database using Golden Gate. So they were trying to simplify the management of one database. They ended up with two databases that they have to manage. So they didn't, instead of decreasing cost, they increased the cost. Instead of decreasing complexity, they increased the complexity. Silver lining is they end up with a hybrid DR for their data. So now that they have a DR solution, which some customers are now doing using the cloud. But the problem with this architecture is it only works for the data. If you lose the local copy, their application will still fail in this architecture because they didn't properly think it through. It was like a unintentional consequence of it. Another thing is, as I said, about the sizing. In the cloud, a lot of these services comes with hardware included. So choosing a service is at the same time choosing a hardware together and a sizing. And sometimes people have this, especially on the cloud side, has some unrealistic expectations, like as if like everything will be magically faster. But you still need processing capability, you still need CPU, you still need I/O, so you need to be careful about the sizing of those things. Don't assume that things will be like 10 times, 20 times faster just because you move to the cloud. Or sometimes people expect, oh, it is in the cloud, I don't have to worry about high availability or DR at all. Things on the cloud never fails. In reality, things do fail. Your pod can fail, your available domain can fail, region can fail. And these different services and products provide different levels of HA and DR. And some of them are built in, some of them are with extra cost, so you still need to pay attention to that. And for sizing, as an example, it's a little bit exaggerated example, but we have seen recently a customer who was moving to the cloud, to ADW, their on-prem system had more than 100 CPUs. And when they were trying to move it to the ADW, they were trying to move it to 4 CPU, look, from 100 to 4 CPUs. Why? Because they were expecting that ADW will be like fly out of the box and it will give 10 times, 20 times performance improvements just by moving to the cloud. So you need to be more realistic and careful with those sizing stuff. And last thing I want to mention is, as I was saying at the beginning, like the way you look at these systems, especially for a data warehouse type of an environment, you need to change your mindset. Instead of looking at them as cost generators, you need to look at them as value generators. And if you build the right architecture and use the data in the right way, they are going to generate way more value than the cost of the system. So instead of worrying about the cost, don't forget to focus on the value it is going to generate as well. This is an old on-prem examples that we have. I put here 2 telco customers, almost same type of data in their systems. One of them use it for doing analysis for their billing and finding billing mistakes. That customer was able to pay for a 2 petabyte system in 1 month by the amount of value generated by the system. The other customer put the same data in a 1 petabyte database, but they don't do any analysis. They just use it for some law enforcement and claims things. So for that customer, this is nothing but costs and generate zero value. So they always complain about the cost, while other customer is making money out of it. And also when looking at the cost of the systems and products, you should also look at the savings that those products provide to you. Things that you don't have to do. Things comes out of the box. Like if you look at the ADW, like the backups are done for you. It includes the graph capabilities, machine learning capabilities, notebooks, ETL tools. So there's a lot of added values beyond just the data store. So you need to take that into account as well. And with that, as I said, I try to get together some of the bad examples for you so that you can look at these architectures in a way that you can implement successfully and not fall into the traps that other customers fall.
Yeah, that would be really useful to delve into further in another call. That was really interesting. Thanks, Jamil.
Thank you.
So with that, on comes Massimo and a couple of colleagues I think he has invited to tell us about the industry architectures that they've been developing. And I believe a few customers have implemented now. Hi.
Hi there. Can you see my slide?
Yeah.
Yes.
Fantastic. It works. All right. Good morning. Good afternoon if you're in a different time zone than North America. My name is Massimo Castelli. I work in the database product management, and today, together with a collaborator of mine, Larry Fumagalli, we'll talk about architectures in a slightly more positive point of view than my predecessor. We'll try to give an overview of the work that we've been doing for the past about 3 years around giving reliable architecture, giving best practices to customer and partners. First of all, I'll talk about the basic of our analytic data platform, also called Lakehouse in some case. Basically, talking about a set of architecture we develop and publish on our architecture center to showcase the capabilities of our analytics platform. Then a more recent set of activities, basically taking those architectures and solving real industry vertical problems, real customer problems with the same technology. And I'll close my presentation talking about automation and the advantage that automating this kind of solution brings about. By the way, if you have any question, just put them on the Q&A. Either Larry or myself will be manning Q&As. All right. About 3 years ago, we launched a new corner of the Oracle.com web presence. It was called the Architecture Center. And the idea behind that was to deliver sort of templates, call it best practices, call it showcase reference architectures for customer and partners to basically guide on the different choices. If you have a look at the portfolio contained in the Oracle Cloud Infrastructure, there are really a lot of available services, and often customers are faced with the choice: which one am I supposed to take for a specific task? So we started creating architectures from very small set of services to cover very specific applications, up to the full data management platform slash Lakehouse, with pretty much all possible ways of interacting with data, larger ingestion, different ways of transforming and consolidating data, Spark, big data kind of transformation using Hadoop, object store to store high volume, high speed kind of data, and the relational world, autonomous primarily with the multimodal capabilities. And then the whole analytics side, from Oracle Analytics Cloud, the data science, the AI services, and how everything fits together to deliver value. So we've taken this thing and we call them horizontal architecture. Horizontal because they are not addressing a specific industry or market use case. They're just a way of showcasing what we can do and what can be done. And again, as my predecessor mentioned before, pictures are nice, boxes with arrows are nice, but it's not enough. So what we decided to deliver together with the architecture pictures, obviously, was a very detailed documentation on what the services do and why we picked a specific service to solve a specific task in the architecture and what are the possible alternatives, so that it becomes a bit more clear by looking at the documentation why you should pick a specific service versus another. And finally, beside publishing those architecture on the Architecture Center, and again, those are the links to those things, and the PowerPoint will be shared, I guess, at the end of the presentation. We decide to also automate everything. I'll talk about the automation at the end of the presentation, but the repeatability, the error-free instantiation of this architecture was something that we decided from the very beginning it should be part of our offering. Now, once we've done that, and we have seen a good response from customer and partners. Just to give you an idea, the two most popular architecture in terms of website clicking are the very small one, what we call the departmental data warehouse, that has Analytics Cloud, autonomous database, and optionally a few other items like a little object store, if needed, data catalog, but really something that is meant to use the power of the database to ingest data, process any kind of data, and deliver it to Analytics Cloud as an analytic platform. The other most popular one is the full Lakehouse, so the completely other end of the spectrum, with the full architecture using all different components. And out of the 200, I think now it's 250 reference architecture published on the Architecture Center, especially the Lakehouse was consistently top 3, top 5 for the past 3 years. So we basically got the feedback, okay, this is something that our customer, our partners really look at. So we started the next phase of the project, that was taking those horizontal architecture and addressing vertical, real customer use cases. And the idea was to leverage the expertise we have in a company like Oracle. You can imagine more than 100,000 persons in Oracle, the sheer knowledge distributed globally around the various employees. So we try to leverage the expertise gained by engaging with you, with customer and partners. We try to enable discussion around how to solve specific problems consistently and faster. And we basically collected the challenges, talking also to customers, and we created distilled a set of use cases. Those use cases, we start creating architectures to solve the use cases. And as my predecessor was saying, boxes and lines are not enough. That's why we took the time and the effort to really go into deep, detailed description, how the data enters, and you see the numbers here. And later, Larry will walk you through one or two of the architecture, just to give you a deep dive into the work behind this thing. How data enters the system, how data is moved through the system, transformed, aggregated, and prepare for delivery in solving a specific use case. And again, this is the first step. You see at the bottom of the architecture things like infrastructure, network security, identity management. As we heard before, those are all attributes of an architecture that needs consideration. And it's a sort of an interactive approach. You need to define a diagram and then basically discuss with the customer, the partners, how to physically implement something. Now, just to give you an idea of the portfolio that we managed to create, and we still expand and maintain, we create a set of patterns for utilities that cover from the more classic use cases like predictive maintenance, focused around our MZ2 service, down to the more very specific, but very, very interesting and very much in demand, the use cases like vegetation management. And Larry will spend some time outlining one of those later. We also cover telco being a very interesting one because it has very large technical installation with specific use cases. At the same time, they need to manage a really huge amount of customers with pricing, with customer 360 kind of interaction. So a really nice industry to create use cases for. Manufacturing, different set of use cases, and we created something down to plant data consolidation. So using our roving edge device hardware to implement lights of plants, manufacturing plants. The same architecture could be used, for example, in other industries like oil and gas to automate the functioning of a drilling station or a wind turbine station, literally in the middle of the water with satellite connection a couple of times a day. Financial services was the first we started with, and we cover here also an interesting side fact. We cover different architecture. You see up top on the left side, live data analysis. A really simple architecture, but you wouldn't believe the number of times our customers in this space asked us for this architecture and how we think it should be addressed. But we don't do just the simple one. We created architecture patterns to cover even complex kind of calculation, especially around the risk calculation that goes into deploying simulation models on top of high performance computing. Now we did the same for retail, very much similar in some cases to what telco are doing in terms of customer interaction, but completely different set of use cases for other aspects, especially around inventory, stock management, all the dynamics of having pieces moving, lorries moving from production warehouses to the stores and trying to consolidate, for example, stock inventory. And healthcare being a huge market, and not just because we have been dealing with healthcare issues for the past couple of years. You may be very well aware that Oracle is focusing very strongly on the healthcare market, but this is a really important market with a set of completely disparate use cases, from the patient experience management, trying to move patient from hospital care to outplacement, trying to keep track of diseases, where they happen, can they be prevented, are there patterns into population geographical areas, earning segment that could be used to prevent the spread of specific diseases. So really interesting stuff. But now, just to give you an example, or first of all, I showed 6 industries. We are keeping up the work and increasing patterns, and more to this on my final slide, on the little call to action I have. But we are working also on defense. We're working on pharma. We're working on public sector, and logistics and transportation as the next one to develop patterns for. But now it's time to hand over to Larry and basically give you a little zoom in on 1 or 2 of those architecture. Larry, is that okay?
That's perfect. Thanks, Massimo.
So let me stop share.
Hi, as Massimo said, my name is Larry Fumagalli, and I work with Massimo developing these architectures. What's unique, or what I like to think about where I come from, and my expertise is I come from a services background. So implementing these, and when we do these architectures and work with the teams to build these out, we make sure they're relevant and new, and then also that any services that we highlight here are actually we've gone through and done these ourselves, either with a customer or our own internal POCs, right? Just to validate that everything works as expected. We did this, and what we've done is, as Massimo discussed earlier, is we've worked with our global business unit, and in this case is the Energy and Water Global Business Unit. All the experts there that have worked in this industry for a long time. We've gone outside and asked third-party conversations. We've done our own research. And we've got these use cases. As we build these out, we don't want them to be stale. We want them always to be relevant. And when our engineers and sales team, we go talk to customers, we want to make sure we're talking to them about relevant use cases that that they're interested in, right? That they want to hear about, and they can easily go, if we do something like this vegetation management, when I go through and describe it, you'll see many of these pieces. You go, wow, that looks familiar. We could probably apply this here, or even in a different industry, right? You can take this kind of pattern that we've shown here and kind of go, oh, if we are a train company, if we're evaluating rails, we can use the same type of process and technology to do that, right? So you can easily interpolate this kind of conversation. So we've tried to do that when we do these, and again, make them relevant, continually update them. We do this continually, and we're in the process of doing that now. So that makes these fun, and especially like I said, when we talk to customers, we want to make sure we're talking about something that interests them also, right? So we've gone through, and in this case, vegetation management is one that someone, team member from the GBU, brought up to me, and I started promoting it, and with the other groups, as at Oracle, we've got a bunch of other vertical teams that we work with here, and they weren't so high on it. But it was interesting as time went on, and I started showing them the value of this, and other people from the utilities industry jumped aboard and had discussions, and they were talking with customers. This actually became very high, right? And especially if you guys read in the news in the last few years or whatever, the expense that PG&E, utility company in California, had to go through because of this problem itself, right? It's in the billions that they've had to pay, and they spent actually billions in doing this vegetation management. So we kind of went through the use case, and then when we go through the use case, we go through the details of what's happening in each step. And as Chemo mentioned earlier, we put all of these boxes here, as you would call them, boxes, lines, and crow's feet, to name an old model, as my buddy would call them, But we put them here to signify what you can do, how we did it, but it doesn't necessarily mean you have to do it the same way, right? These are our suggestions. These are from what we've done and we've seen work, but they don't have to be the way we do. And we actually show all these also to make it easier we show all Oracle tools, right? You can, in many cases, customers have other tools that they've already settled on, right? So you can easily plug and play those tools into our diagrams that we show here. Like maybe for example here, I'll just go through a highlight, just kind of what we did from a vegetation management. Vegetation management, the key things you want to get from there is, one, the big key is LiDAR data. LiDAR data or satellite imaging data you can also use, but LiDAR is better. It's a laser type imaging that is done usually with drones. And what it does is it gives a 3D image of the environment and other structures and stuff. So when being evaluated, you can see, in case of vegetation management, you can see, oh, those trees are glowing high next to a transformer or close to wires or stuff like that. Because in the past, when utility companies had to do vegetation management, this was all very boots on ground. They sent out people, as you've probably seen in your own neighborhood, guys walking down the street or gals walking down the street, looking at the wires and evaluating, are those trees getting in the way, right? If they are, then we go manually do that, right? And so instead of having that boots on ground and having that expense, utility companies are now evaluating using these drones to get those LiDAR images. But to do that, right, you don't want to have people looking at those LiDAR images all the time. And so as you're bringing this data in the other data sources we bring in, of course, our weather data, location data, outage to go through previous ones, right? So they can go, yeah, in this area 2 years ago, we had maybe a tree problem. So let's make sure we investigate that today with these LiDAR images, right? And send a drone out in that area to investigate that stuff and predict what's happening. And then also go along with, we bring in maintenance logs and that type of information. So as that information comes in many of these different types of ways, we take all of that data initially, and we, besides doing it into, if you want to do, in this case, when the model is built, you might want to put that into a complex event type processing system. That's a capability, but we also take all of this data and move it into object storage. So that way the machine learning can be executed upon it to evaluate it. And then also here at the earlier steps, the AI services can be done. And this is the evaluation of, you've already labeled some data that's a tree, that's a transformer, this is, and you can understand the height of all that type of information. So you've labeled that data. So now you can utilize the AI services and the analysis they do on some of those labeled images, do your data science to build your models, deploy your models here in the streaming analytics. So as your data comes in, you can evaluate it each day, right, to determine, and then also automatically visualize that data, right? So people can go visualize and say, all right, I can see the LiDAR data and I can see it says we need to do work here, and I agree with that, and do that type of imaging. And then finally, you can actually push that data out via, APIs, right? So your applications then can consume that information, right? So you can interact with your maintenance logs, right? Instead of people having to put boots on ground, now they can be automated, right? They can say, oh, let's go to this area, and you can also prioritize, right? Maybe you're going to be based on history, go to point X, and you now would go to point Y, right? Because that will take priority. And what's even nicer is you do these visualizations, you can also predict, make predictions in, if we don't do this maintenance, what will be the potential electricity loss? So all of that can be embedded into this this little diagram here. It looks simple, and we do, when when our teams go out and talk to the customers, we have much detail under here that describes all of this, what type of data, all of this type of information, to allow our engineers to best speak to customers and help them out. I hope this helps, and back to you, Massimo.
Thank you very much, Larry. Let me pick up where I left. Here we go. So as I was saying, the final piece of my presentation talks about automation. And from the very beginning, we decided to add automation in form of Terraform scripts to all the work we have been doing, especially around the horizontal architecture. Why the horizontal? Well, simply because the vertical ones use the horizontal starting point. So it doesn't make a lot of sense to create one specific Terraform solution for all those patterns you've seen before. we rather give a high quality Terraform solution for the horizontal, let's say, templates, and then we can help customer partners adapt them to specific use cases. Now, in order to do that, we created a public GitHub repository. We call it the Cloud Foundation, and we created a reusable terraforming library. So it's a module library that you can refer to from any other Terraform file, or you can clone the whole repository if you want and deploy everything inside your own company to avoid any external references if that way you prefer to work. And this is completely open source, so it's something it's there for you to use, and not just a library. We also created solutions for each and every of the patterns we created on the horizontal patterns, plus additional things we thought it would be really important to offer, like monitoring, observability. An architecture makes a lot of sense if it can be monitored, if you can look at what happens, if you can read KPIs out of it and see if everything is working fine. And in order to do that, we created a layered approach to monitoring, so that you can add the complexity to the monitoring by simply deploying terraforming scripts. Why is this important? Well, it on the one hand, it avoids mistakes. It's a script we automatically test every week those scripts. So we know that even if something changes in any services, something in our OCI environments need to be adapted, we know it and we fix the thing. So we are pretty sure that inside the last week, all those terraforming scripts still work, so they can be used and replicate. The other thing is the capability of replicating environments whenever you need to. I used to do monitoring for a living many years ago, and we had to manage in a large Swiss bank. We had to manage development, system test, and production. And obviously, you have three completely separated environments in this kind of setups. But still, you want to be able to create sensible monitoring on top of that. And it's literally hundreds of databases, hundreds of WebLogic or open source or any other components working together. And you need to configure them to define the various alarm thresholds and everything. Well, what's best than do it once in something like a Terraform script and then deploy it? You want to change something, well, it's pretty much already documented. You can even check in, check out of a code management system, the terraforming script, and you got pretty much automatically documentation. So again, if you want to profit from this repository, feel free. It's really there for you to use. Now we are moving into a new phase of this work, adding not only the infrastructure, but also content. And just to give you an idea of what we are doing, really, literally as we speak. So we plan to finish this project by Cloud World. That basically means the second half of October. So we have taken Autonomous Database, Analytics Cloud, and we decided to load on top of that a data model. You may remember that a few years ago, Oracle had on the price list a number of industry data models. We still have them out of the price list. So if someone is interested, we have them as free item. And we decided to take, for this particular project, the manufacturing one, that is really a complex piece of data engineering, and load it on Autonomous, load some test data, connect everything to the data catalog, and preload Analytics Cloud with a set of KPIs, measurement, dashboards, and all it takes to have this configuration instantiated, it's basically press a button, go for lunch. After 40 minutes plus minus, everything is installed. You get the database, you get the data model, you get test data preloaded, You get Analytics Cloud pointing to that, data catalog pointing to the data. And instead of working 3 to 5 days to manually do everything, it's now done in less than 1 hour. And I think it's a powerful thing to enable people with an interest in a specific vertical in this case, but also people that has an interest in trying out our software and see the capability of what can be done in such a constellation. Well, it just doesn't take a lot of effort. Press a button, go for lunch, come back, and everything is there ready for you to try out. And again, this is something that we plan to release to the public by mid of October. Now, my final slide is a little call to action. This work makes sense if we exchange. So we interact already with customer partners. For example, Wendisco is one of the partners. We had such exchanges in the past. We even published an architecture together. And we will really like to extend the invitation to work with us. If you have an interest, if you have feedback, if you want to look at what we did and share experience, give us feedback, take input, up to if you're thinking about a use case, how to solve a specific use case that we don't have, we are very willing to work with you and solve it together. So please do reach out. I'm in Switzerland. Mike Blackmore, that for family reason today couldn't join, is in the UK, and Larry is in North America. So we cover pretty much between the three of us all the time zones. So just reach out if you have an interest. We're more than happy to work with you. And again, if you have any question, I'm staying on the call, so drop them in the Q&A. With that, thank you very much. And I guess, Laura, back to you.
Yeah, thanks very much, Massimo, and I will keep customers in the loop on what you're doing. And I will share the PDF, everyone, so that you can click on the links. I'll make sure that they're enabled so that you can take a look at all the scripts and all the material. Thanks very much. Okay, and now we are on to Sinan.
Yes, thank you, Laura. So you share my screen and then start. So good morning, good afternoon. My name is Sinan Petrostoma. I'm part of the high availability, scalability, and maximum availability product management team, and focus on multi-cloud high availability, which is the topic for today's presentation, and especially talking about the newly released Oracle Database Service for Azure, or in short, ODSA, and how does this simplify multi-cloud deployments. In the first few slides, just to be on the same page, we will talk a bit about the terminology, what is multi-cloud, the benefits, and then the challenges, and then how, or what is ODSA, and how does it solve these challenges, or simplifies them at least. And then we will have a look at different multi-cloud reference architectures at the end of the presentation. If you have any questions, please drop them in the Q&A session, and I'll have a look at them at all. So just to be on the same page for the terminology, as different people talk about different things using different terminology. So with hybrid cloud, we usually mean there are some workloads that are distributed across your on-premises data center and one public cloud service provider, like having the application in the database, or having usually a hybrid data guard deployment, having the primary on premises, which is protected by a standby in the cloud, for example. Or many companies now use multiple cloud providers for different workloads, having one workload in one cloud and having the other workload in another cloud. This is more considered like having multiple cloud providers, using service from multiple vendors. But when we talk about multi-cloud, we are usually referring to a workload that is running across multiple clouds at the same time. We'll have a look at this. For example, having an application in one public cloud provider while having the database on another cloud. So this is what we here call multi-cloud or multi-cloud. And why customers do this? There are multiple reasons, but one of the most important ones, and what we see much more frequently, is to choose the best-in-class services. Like customers have their Azure applications running on Azure, but they still want to use an Oracle database running on Exadata that is only available in Oracle Cloud. So to choose from each cloud provider the best services offered there, or like an autonomous database in Oracle Cloud, and to combine these and run their workload across these cloud providers, but using the best services from each cloud provider. You could also use clouds as mentioned by Jamil before. Things fail, even a cloud region fail, and we have seen this in the past from many major cloud providers, even that they had outages. So you can just replicate your workload across multiple cloud providers with a load balancer in front of it, and then distribute the workload, and then have your high availability solution that is running across multiple cloud providers. But also move data across clouds, or having like a disaster recovery solution where you replicate data across clouds, and using this also to move data and migrate data across clouds. If you decide one day to leave one of the cloud providers for whatever reason and move your workloads to another one. But also different services have different prices at different cloud providers, and for sure you want to benefit from the best offerings, and based on that you will choose what cloud provider to run which services. For sure, such a multi-cloud architecture comes with many challenges, like managing security and users. You will need to manage and monitor your workloads. You will need your staff have the expertise in managing the services across multiple cloud vendors. They use their different terminology. They use their different terms and terminology for the same things. But first of all, you will need to connect these clouds to each other. So to build a network connectivity across these clouds, across your tenancy, across these cloud vendors, so your resources are connected to each other across these clouds. And this comes also at some additional cost for establishing the network connectivity, depending on what to choose, but also paying ingress and egress network traffic costs. And to simplify this multi-cloud connectivity and multi-cloud architectures, it is a while now since Oracle and Microsoft partnered in 2019 and had this Microsoft Azure and Oracle partnership that provides the Azure and to OCI interconnect that simplifies setting up this network connectivity, that you don't need a third-party network service provider, that you just go into the Azure portal, you log into the Azure portal, you log into the OCI console and do it yourself. It takes you maybe 20 to 30 minutes, and you set up this private and dedicated interconnect with low latency and also high availability, less than milliseconds latency across the clouds, because we provide this where we have data centers now, 11 data centers across the globe, or 11 regions across the globe, where our data centers are very close to each other, so we can provide this low latency network, but also a collaborative support model, so customers can raise their support tickets to either cloud vendor and work on the issues. And for sure, as mentioned, running the best in the class services on each cloud. If you have like Power BI running in Azure, you can use an autonomous database or an Exadata database service or an Oracle Real Application Cluster on the background for your analytics platform on OCI. So, and this Azure Interconnect simplifies the network connectivity, which is one of the most obstacles when it comes to connecting clouds. Also provides an availability SLA, high bandwidth. You can deploy multiple connections and multiple express routes and fast connect. You don't pay an egress rule charges. And as mentioned, it doesn't require any third-party network service provider because this connectivity is provided directly by Microsoft and Oracle. But now with the database cloud service for Azure, this has been taken to one step further. This time, you don't even need to go there and deploy and implement your own OCI Azure Interconnect. This is done by Oracle. Oracle provides an Oracle-managed Azure Interconnect that automatically configures the connectivity between your VNets in Azure and your VCNs in OCI, and Oracle takes care of management and monitoring of this interconnect. So you don't need to have the networking skills to learn how to set up express route, how to set up fast connect, and do all this networking stuff. This is all done in the background in a guided manner for you when using this service. On top of that, this is especially very interesting for customers that are only using Azure yet, and they are not familiar with the OCI console. Because this service provides an Azure-like portal. This is a different portal from the OCI console and a different portal from the Azure portal that looks like an Azure portal, but it is not. And it's provided you with the same experience of provisioning resources, in this case, the Oracle databases, an autonomous database and Exadata database that are actually running in OCI, but you're provisioning them through a portal that looks like Azure and using the same Azure terminology and the same Azure workflow. So it looks like for you like Azure. You don't need to learn any other portal, any other terminology. You just use it as if we're Azure, but actually it is not. And it is provisioning Oracle high availability databases for you in OCI, where you then can connect to them from your applications in Azure. Okay, and on the other hand, the databases that are provisioned in OCI, then they send metrics and events to Azure Application Insights and Azure Log Analytics. So you have these logs and events all together with other logs and events from your applications at one place. And the good news regarding cost and billing as well is that this service is for free. You don't pay for the interconnect as if you would set it up manually, as you have seen in the previous slides, where you would pay for the express route and the fast connect port per hour. In this case, you won't pay for it. It is a managed service by Oracle, which is based on an Oracle managed Azure interconnect in the background. So you will just use it. You will get a tunnel, a private secured tunnel that connects your Azure VNet to your OCI VCN, and use it to connect your applications in Azure to your databases in OCI for no additional. For sure, you will still continue to pay for your Azure resources, for your VMs running in Azure, and for the databases running in OCI. And also you can see then the billing in this multi-cloud, or what we also call it, the ODSA portal. There is a page for billing that shows you the bills for the resources that you are using, but you still continue have your contracts, your payment differently to OCI and to Microsoft. This wouldn't change. And with this, ODSA solves or at least simplifies a lot the challenges we talked about, setting up the network connectivity, having the costs for ingress, egress, and ports. You have a unified management and single sign-on portal, because for the cloud portal for OCI and for Azure, you can still use your single sign-on with your Azure Active Directory. All events and logs are sent to Azure Application Insights. And you have this multi-cloud portal, which has a look and feel of the Azure portal, so you don't need to learn an OCI terminology and navigate through the OCI console, even though it is still very beneficial. And I can only encourage you to do this. It's very simple as well. It's very straightforward to navigate through the OCI console. Also because at this stage, not all the functionality is provided by the ODSA portal. So sometimes you still need to go through the OCI console to do some management tasks that are yet not available through the ODSA portal. So here we have a summary of the differences and similarities between ODSA and when you implement an Azure to OCI interconnect yourself. Especially here, this is customer managed, and the ODSA is Oracle managed. Here you pay for the port and gateway, and ODSA is completely free. The thing is, when you use ODSA, you can only connect to Oracle databases in OCI. ODSA allows you to create only Oracle database resources of the base database service, Exadata database, and autonomous database on shared Exadata infrastructure. And you can only connect to these database services through that Oracle managed interconnect. While when you use OCI to Azure interconnect yourself, you can connect to any OCI resources. Okay. So you would usually use the Azure interconnect when you want to connect your Azure resources to any OCI resources, not only to the specified Oracle databases database services we mentioned before. And when you have the experience to set up and manage the interconnect using Fast Connect and Azure Express Route yourself, you are aware of the additional costs for the port and gateway charges that comes along with this Azure interconnect. And also you are familiar with the OCI console and how to provision and manage the OCI resources. But as mentioned, this is very straightforward, and you should be able to do it anyway. And the ODSA simplifies everything. It simplifies the provisioning of the Oracle databases in OCI. It gives you the opportunity to provision them as they were like Azure resources without dealing with any network connectivity, without dealing with setting up any express route or interconnect resources, without dealing to navigate through the OCI console, and also it saves you the interconnect cost entirely. Okay. In addition to the Azure Interconnect and ODSA, if you want to provision your multi-cloud architectures in regions where we don't have this Azure Interconnect, or when we are not talking about Azure to Oracle, but like AWS to Oracle or Google to Oracle or other clouds to other clouds or other clouds to Oracle, there is still possibility to use VPN, more kind of for POCs, but when it goes to productions, you will want to have a reliable, dedicated private network. You can still use third-party network service providers that provide managed connectivity between the different cloud providers. And the different network connectivities differ at some points, especially here it requires third-party network service providers, because this adds additional complexity, but also additional costs usually, because these third-party providers, they charge you for their services as well. These are not needed for the Azure Interconnect and for ODSA, which makes things much more simple. For sure, the reliability is very important. So to choose third-party provider or the interconnect when we are talking about production systems, here reliable, while the VPN depends more on the public internet. Egress costs, they are not involved when you are using the private interconnect, but egress costs are there when you use the public internet. On the OCI side, you will have the first 10 terabytes per month for free, which is quite good, that you can use them for POCs, for example, without getting charged for egress cost. Okay, and as shown before in the previous presentations, we have the Oracle Architecture Center, where we continuously publish different reference architectures and also solution playbooks, how to implement them. So not only showing the boxes and the arrows, but also showing how to implement them, the descriptions for these architectures, the best practices for these architectures, the recommendations, the considerations when implement these reference architectures, but also solution playbooks and the step-by-step guides when how to implement these reference architectures. And I want to show you these here in the browser. So if you just go to this Oracle Architecture Center slide page, the slides will be shared afterward. So you just go to click on the link and search for multi-cloud. Then you will see all reference architecture, solution playbooks, and built and deployed, and also that are related to multi-clouds. And here are the examples shown also on the slides to implement the what's called split stack solution architecture across multiple clouds, like having Power Builder applications on EC2 AWS and Golang and .NET on GCP, which was just recently published based on a real customer use case, and using the autonomous database replicating by autonomous data guard across 2 regions in OCI, and then the description of this architecture, description of the components, the recommendations and the considerations, and then much more informations to explore more. And this design or this flow, like having the architecture and the recommendations, the consideration and how to deploy it and to explore more. This is exactly the same for all the reference architectures in the reference architecture center. So it gives you a consistent way to learn and to go through these reference architectures and to explore more and to see how to benefit from them. For sure, here and there, you might need to adjust this architecture to meet more your use case, but this is a very good starting point to take and start from there.
That's fantastic information, both yours and Massimo's, and I'd really like to invite you to present to this audience again in maybe 9 months or so to give us an update. Do you think? I think that's a good cadence to give everyone an update. Things are moving fast.
Sure.
That's a very good synopsis there.
Yeah. So and more and more of these architectures are being released. So you can just go there. It's also using working with our partners and working with multiple partners. So you see we're working with Cold together. Here working with Megaport, and here you see working with this is the Azure Interconnect, and here working with Equinix and working with multiple third-party service providers, with Oracle partners to implement or to provide the connectivity across multiple clouds, multiple cloud vendors.
All right. So if there's any questions for Sinan, he'll be around for about another couple of minutes, and he has to drop. Is that your last slide, Sinan?
Yes, I'm coming to the end. So
Okay.
this is just how the reference architecture would look like across multiple availability domains and multiple clouds. This is across multiple regions, like using ODSA or the interconnect between, if it is an Azure to Oracle, and the internal network, the backbone between Oracle or Azure or AWS or whatever other cloud you are using. And if there is any questions, please, this is my email address, let me know. I'm always happy to jump into a Zoom session with you and discuss your use case and answer your questions. Thank you.
All right, thanks so much. And Derek, are you there?
I'm here. Hi, Laura.
Hey, right. So give us an update on what's been happening with your implementation. So in a nutshell, you implemented some autonomous data warehouse projects, and now you're progressing with putting your entire data management.
Yeah, so is this,
On
can you see
ADB?
this?
Yeah.
Okay, good. Okay, so I'm going to make it quick at Laura's request. I think a lot of you, I recognize a lot of you on the call. You probably know us. Some of you can probably give this presentation. But been a long journey for us. We've started 8 years ago on the cloud, which I think is unique. We're not a cloud lift. we're not really a cloud lift story. We're more of a cloud born story. So we were in DBAS and BIX, back in 2000, and I don't do math. But anyway, so it's been a while, and we've been slowly adding functionality into the environment over time, and I think we did a really, really good job of kind of govern BI and reporting for a few of our user communities. And it kind of got the momentum of a data warehouse and reporting going in the company, but it's been a little bit stale. I think coming into November, we did a few things with Spatial Studio over the last couple of years. Obviously, we moved to autonomous from a data warehousing standpoint. We actually used it in a use case with our marketing data when it first came out, and that's still going strong. But we have definitely had a problem with relying on file transfers and just a lot of really bad data practices. So we did start with kind of an MDM initiative last year, and we started expanding our footprint. And over the last few months, we have, oh, it didn't work. Okay. Well, there we go. There we go. That's better. So over the last few months, we've actually been pretty aggressive in expanding our solution, a lot of work on the integration side, and really bringing a lot more data sources into our world. And I'm taking a bit of what I call a field of dreams approach. Like if we build it, they will come. I felt there's a lot of hidden data out in our company that still sits out. Some of it's in plain sight, some of it sits out on AWS, some of it's in Access databases, things like that. So we're really trying to enable a true Lakehouse culture and expand our community, which we have. We've actually in the last year brought in our operations team, our sales strategy team. And so we've really we've enabled a lot more users over the last year. We've been doing a lot more, I would say, insights and enablement of data exploration. Some examples are a competitor database that utilizes vision to do some identification, real estate playbook for our municipal strategies on how to get new inventory into the market, done some data science around billboard personalities and pricing outliers, and optimizing our charting, which is our inventory, how our inventory is placed in the market. So that's kind of been the last 9 to 12 months. And then really the future state is to kind of bring in some of the advanced concepts like streaming data, data catalog, a lot of the things around data policies and Cloud Guard, those type of things, and really expand it to everybody in the community. And so I think that's kind of where we're headed. I think we're kind of an enablement story, like how you can enable this and enable it over time. I apologize, it's a lot of arrows. I feel like I fell into the trap of a lot of arrows, but it really does work. So hopefully that's the quick 5-minute, yes, this stuff does work, and it does work over time. So happy to take any questions or speak to anyone offline about what our experience has been.
How do you keep abreast and architect this? Is it through listening to webinars like this, going to conferences?
Yeah, global leaders. I mean, you guys have been really good about helping us find resources internally at Oracle to help us deploy this, and kind of, I think Shamil probably alluded to some of the bad practices that we may have had in the past, kind of right the ship. So you guys have always been really good about helping us find resources to architect this correctly, because it is a lot, and there's a lot of deployment happening of new items and new technology all the time. So it's hard for us to keep up and
But
try
the
to map our use cases to the new technologies. But
the presentation such as today from Sinan and Massimo, is that a good point for you? Did you need that earlier?
No, absolutely. And I think, we're definitely in the Microsoft Azure space a little bit. And I think that's something that I will take back to our team and just explain, like, we do have these multi-cloud strategies, and our partners do have solutions to make all this work.
Okay. Well, thanks for sharing your update.
Sorry, that was so quick, but you said quick.
Yeah. Okay, thank you. Any questions? Let Derek know in the chat or Q&A. And there's a question there for you.
Nope.
From a customer. Okay, Peter, thank you.
How long? Tim Miller, you know how long. How long have I known you? I think the first 5 years were very rudimentary. We started enabling kind of some advanced concepts within the last 18 months, but the real integration work happened, or the real heavy lift happened over the last 9 months. So it happened. We did engage with the Oracle Cloud Lift to help us with that, which I think was definitely a enabler to get us here much more quickly.
Okay, and how much longer do you project it will take?
I'm not sure it'll ever end. No, I really don't. I mean, I don't mean to say that as a joke. I think it'll be iterative, and we'll always be adding on it, as use cases and technologies arise. I think the important thing is, for us at least as a company, to come here first with a use case and say we can do this here, rather than kind of have arbitrary data stores out there that are really not supported.
Yep, very good. Okay, so Peter, tell us about data mesh and the strategy that's...
Sure, thanks, Laura. Can you hear and see?
Yeah.
Okay, I'll try to move fast here and preserve some time for Tony and Wendisco within the boundaries of the time allotted. We're going to talk about some changes happening in data integration, modern technologies for our real-time data mesh, and how Oracle's Golden Gate fits into that. There has been an inflection point, and there is no going back. And I'm sure a lot of you, as architects and part of this council here, have heard and read a lot about these changes. Even my boss, Jeff Pollocker, VP of Development for Golden Gate, he's put together an ebook and a tech brief that you can see here that I've pulled some slides from, called them for this presentation. There's a lot of press about this, a lot to read, and I've included within this presentation links to those articles. And including in that are not just specific writers, but major industry analysts like Gartner and Forrester, from data fabrics and data mesh. These are the new strategic trends. These are the critical capabilities that are feeding into their reports and their analysis. And we had also learned during our recent Golden Gate Customer Summit that 70% of our customers either had a data product strategy and or a data mesh or data fabric strategy. So this is the new paradigm, and why customers are moving there, why the industry is moving there, is because they need to. A lot of these digital transformation attempts fail. The monolithic architectures of the past are just that. They're arcane. Companies can no longer afford to invest in dumping all their data in one warehouse or in one cloud in these monoliths, because if and when they fail, and they will, there's no getting back from them. Cloud lock-in is real, as my predecessors speaking today have mentioned, and that can become really expensive, mostly due to egress fees. A lot of these data lake initiatives, Hadoop-based initiatives, they weren't that successful. And when they were very specific to just analytics. And organizational silos are splintered, and that can exacerbate such issues. So while everything's speeding up and your competition as well is building up, the cost of operational outages, as my predecessors were just referring to, is astronomical. You can't afford downtime, whether that's scheduled or unscheduled. So data mesh kind of bleeds across all of these, alleviates these concerns, and allows you a more agile approach, a more distributed approach to address these concerns and move into digital modernization with a lot more flexibility via a distributed architecture. But within all this press that's out there, all this paper and all the buzz, beware of the hype. There's really no single product out there that's a data mesh. There's no single vendor that can really provide you with all the different bits and pieces. At Oracle, we like to think we're pretty close, but it's not just a single cloud or lake with doing just the analytics. It's not just a catalog or graph. It's an architecture. It's an approach that's data mesh. And it's a little bit different. Data mesh and data fabrics, people have different specific definitions of them, but across these, there's really a mind shift towards data product thinking. Again, our customers, a lot of those polled came back and said, yeah, we have data product managers. Some companies even have a data product marketing group where they're making better use of these data products, that they're owners of their data on the application side, on the OLTP data side, the DBAs and system owners. They're outputting these data products for consumers, and these data products should be self-sufficient in the formats and in the time and the kind of content that the consumers really want for those. Another common theme across these, it bleeds across operational and analytical domains. You really have to have that data product thinking feed into those meetings to align these. These can't be separate parts of your house. Your OLTP and your ROLAP teams, technologies, and flows and applications really need to be synchronized, and you need to remove that IT middleman. Again, self-service data products generated by those product owners. And a real key aspect that's common across this is to make the most of data in motion. It's not good enough to just periodically, nightly, weekly feed these data warehouses because your batch windows are shrinking. The amount of data that you have on the OLTP side is still growing exponentially. And you need to feed these warehouses, feed them in real time, feed these marts, feed these lake houses in real time. But while that data is in motion, there's a lot of benefit and value you can glean from that in motion. So at Oracle, our definition goes a bit beyond Zermatt Deghani's definition of a data mesh. And I provided a link here. That book is free, by the way, and there's links sporadically throughout this. So you'll get these slides and a recording, but you can download everything from it through these links. Deghani is very much focused on analytical use cases and those principles. At Oracle, we take things a bit further. We like to blend together the operational and analytic and that focus. A lot of focus we also put on trust. Not only must your data be timely and your analytics done on fresh data, you need to trust that data. You need to know that a committed transaction on your source side is then propagated on the target side. So you're looking at the latest and greatest version of the truth without dropping any of that data. So low latency will move that data across for you, high volumes, but you can trust that data. And we like to elevate the data in motion. As mentioned a bit previously, doing analytics on that data in motion with thresholding, with alerting, allowing you to not only make better business decisions in real time, but to take better actions on that data because of geospatial analytics, because of time series, because of AI and other ML being applied to these flows. You can take better, smarter business actions on that data in flight. So it's not just a specific data lakehouse or an EDW that comprises a data mesh or a data fabric. That's a very important part of it. But again, in our perspective, you need to marry together the operational and the analytical side of the house. Here I've culled from Jeff's ebook and tech brief the four main principles or primary attributes to a data mesh. Data product thinking, we talked about that some. Making your data, turning your data into useful products that can be propagated throughout your corporation. Decentralized architectures is also a key. A lot of the speakers prior to me within this session today talked about multi-cloud, talked about hybrid, talked about bridging that on premises to not just one, but multiple clouds. And that's what data mesh is all about. Various isolated workloads with optimized security across those. It lends towards scalability, ease of use, better security. There's a lot of reasons to decentralize your data. We'll touch upon that. And then you have event-driven ledgers. These ledgers might be transactional database transaction logs. They could be schema registries in Kafka. It could be IoT type logs as well, but you're leveraging these and using ACID, using these transactional capabilities to ship data, to transform data, to synchronize data across these distributed architectures. So you can leverage those ledgers to trust that data more. And this, of course, needs to be across a polyglot of different sources and targets and data formats. One consumer of a data product might just want a BI report and a fresh BI report. Another might be a data scientist who wants raw data, wants Avro or JSON data pumped into a lake. There's various forms of data products. We'll talk a little about them, but we need the flexibility within a data mesh to output those in a polyglot. And also what you can glean from these articles and books that we'll share links with you for, it maps into various use cases. And these here are horizontal, but we've gone and taken another step within some workshops we provide in data mesh demos to map those to vertical applications like Massimo was talking about prior. And same as Larry. So across the board, you could have these point projects or strategies that data mesh might feed into. But as MIT gleaned, by integrating the real-time operational and analytics together, you can make better operational and strategic decisions. And that falls within these type of use cases: app modernization, ingesting data into warehouses, building data pipelines. It can be integration for operational reasons, like data availability, HANDR, or it could be for analytics, feeding those warehouses and marts, and just event sourcing. It should all be event-driven, your data integration via a data mesh. So a lot more to read them. I won't drill in too much here, but decentralized data benefits a lot of different purposes. Sinan talked about hybrid and multi-cloud. A data mesh architecture is part and parcel of that. It's no longer monolith. Hub and spoke is great up unto a certain extent, but when it comes down to it, more and more of our customers, an additional poll we did during our Golden Gate Customer Summit was, how many clouds are you using? What are you for your running Golden Gate and your sources and targets? And it was surprising for us to learn that most of those customers, not only do they use us on-prem, but they also use us in multiple clouds, in OCI and Azure, and perhaps AWS and GCP as well. So it's an important part to be able to move your data, synchronize your data across those different endpoints in a hybrid multi-cloud, because you don't want to be locked into one cloud. They have various costs associated and egress fees, and one might have better HADR resources than another and so forth, or you might acquire another company with yet another cloud. So it's important to be able to operate within these data mesh paradigms. And now we'll jump into how Golden Gate can help you do that, how it enables a data mesh. And you don't just have to take my word for it. Across data fabrics, across stream analytics, and across data integration, our Golden Gate software has been a leader. We're in a position of thought leadership and ability to execute. It's 14 years now. We've been a leader in the Gartner data integration Magic Quadrant. Yet again, this year, we've been elected a Customer's Choice Award, voted purely by the customers, not the analysts. And again, at the bottom of this slide is the link to the 2022 Magic Quadrant. So you have that available to you. And a lot of you are probably familiar with how Golden Gate, what it provides in terms of CDC, change data capture, data replication. Very often your first exposure to that might be for a high availability disaster recovery, trusting your data, trusting us to have that, provide you with that 5 nines of availability. But perhaps you didn't know about the streaming analytics that we provide within Golden Gate, the pipelines that you can build, the continuous transform and load pipelines that you can build with the Golden Gate technology, and also the governance you can achieve. Trusting that data via the metadata that we propagate within the trail files that you can ship across these distributed architectures, which has, the insert, update, deletes, who did what, when, and where to that data for compliance, for audits. But you also get that governance through the data validation, the verification we can provide with Veridata is an extension of Golden Gate. Golden Gate Veridata allows you to check the synchronization of sources and targets, to compare and repair the differences between those, and it's all provided and integrated within a metadata catalog. Plus you have that granular security through authorization, as well as encryption through these Golden Gate services. And it's really the trail logs that allow you to operate Golden Gate and enable a data mesh, if you will. Golden Gate works different from other data integration tools. It can be used heterogeneously or homogeneously, but it works at the transaction log level. It does not issue a select star from table to pull data out and thusly compromise or impact those very often OLTP systems that are mission critical to your business. Fewer and fewer of our customers will allow for an ETL tool, a data virtualization tool, let alone a BI tool, to point directly at an OLTP source during business hours. And your business hours are no longer 9 to 5 during the weekday. So your batch windows are shrinking. You're operating 24/7. Golden Gate allows you to capture change data from underlying transaction logs. Very low impact on those sources. And it's a push process where we're pushing and propagating just the change data, saving the network bandwidth because it's only change data moving across that network. You're only transforming the change data, not that whole data set select star from table. And you're only feeding downstream, saving processes not only on the transformation, but the apply process, because it's just change data. But we can output that data across that polyglot of different data products and formats, XML, JSON, Avro. It can be, we'll replicate not only the DML, but the DDL. We'll keep up with that schema drift, and we'll provide those data products, will enable your data owners, your application owners, your DBAs to output data products for your consumers that are self-service. And it's not just for Oracle products and sources and targets that Golden Gate enables. It's a myriad. It's a combination of thousands and thousands of different sources and targets. So it's a very heterogeneous product. We can capture from change data and source from things like MongoDB and Cassandra and feed that downstream. IBM's DB2, SQL Server, PostgreSQL, MySQL. So we go well beyond the Oracle databases, and same on the target side. And it's not just with these data bases and sources and targets that are hybrid and multi-form from our perspective, but it's also third-party clouds beyond Azure and that interconnect and fast connect. We can do fast connect with other clouds. We're fully documented and fully certified on all the major clouds. Of course, we run on OCI, and we have native cloud services for OCI Golden Gate that support Oracle, and as well as heterogeneous sources and targets like MySQL, like Kafka, like object stores. But you can run the Golden Gate components from a data gravity perspective as close as possible to these sources and targets, whether they're Google BigQuery, Azure Synapse, S3, and what have you. And this allows you to truly achieve a global transaction fabric. We have many customers replicating data, synchronizing data around the globe, but perhaps keeping some data local because of compliance reasons, but they can propagate other amounts of that data. So each and every one of our Golden Gate releases has that distributed data in mind now. Now come 23C, our next release, Golden Gate will be purely microservices architecture enabled. The older classic architecture has been deprecated in 21C. So come 23C, which will be a future, and we'll do some launch activities at Oracle Cloud World in October. We'll talk about that further. But the 23C will be purely microservices architecture. And in each and every one of these releases, some other common themes are, we're aligned very much with Oracle's database in terms of numbering. Data type support and functionality and features will be in lockstep with those. Each and every Golden Gate release has improvements in performance and ease of use. And more and more sources and targets are added to each and every release here. And that goes for on-prem as well as in the cloud. We're still fully investing, unlike a lot of other vendors who are robbing Peter to pay Paul, moving all their resources to pure cloud solutions. Where what we roll out in the cloud, we also roll out on-prem. There's new releases of Golden Gate, same as the database, just about every year.
Well, Peter, I think it would be great to have you come back in November 30th in our next installment to these customers and talk.
Absolutely, Laura. Yep. I'll jump to the end here. There's more here that people can dive into at their own leisure, including customer references, utilizing Golden Gate. And the last slide has some next steps, data mesh workshops that our sales and consultants provide. And there's a lot of good links at the end to learn more. So I'll spare some time for Tony and Wen Disco. Thank you.
Yeah, absolutely. We'll have you back on November 30th to give a Golden Gate update, especially after the Oracle Cloud World announcements. That'll be great.
That would be great. Thank you, Laura.
Thanks so much. Okay, Tony.
Okay, share. All right, hopefully you can all see that. So thanks, Laura, and hello, everyone. My name is Tony Velsich with Wen Disco. We've arrived at the final session of the day, so thank you very much for hanging on through the kind of 2-hour session. There's definitely been a lot of great content today, and hopefully I'm going to make this last 10-15 minutes worth your while as well. So in terms of the agenda, what I'm going to do really quickly is provide you with an overview of Wen Disco. Make sure you're familiar with that. If you haven't heard of us, and talk a little bit about our partnership with Oracle. As we've been kind of discussing, and really what Wen Disco enables is organizations to accelerate and ensure their successful migrations to the cloud. And I'm going to talk about some of those specific use cases where we get involved and how we ensure those successful projects. And then lastly, I'll cover kind of what makes Wen Disco different, right? And how we can help reduce the costs and risks associated with these large-scale data migration projects. Okay, so WANDisco has actually been working with Oracle and their customers really for a number of years. However, it's been really renewed, or our partnership has been renewed at the beginning of this year, right? We formally announced it in January 31st press releases that you can see images of here. You know, it was really as part of Oracle's Cloud Lift Services relaunch, right? And WANDisco was introduced as the latest addition to Oracle's Cloud Lift Services with a specific focus on, again, enabling this fast data migration to Oracle Cloud Infrastructure, with really the primary focus on migrating, you know, the Hadoop data and Hive metadata from an on-premises, say, Oracle BDA into this Oracle Lakehouse architecture. And we'll talk a little bit more about that. As for use cases, you know, the primary way that we've probably worked with Oracle in the past was to, you know, replicate Hadoop data between, you know, say 2 or even more Oracle BDAs, really to set up kind of disaster recovery environments. That's been the way we've worked with Oracle in the past. Most recently, and really what I'm going to focus on today, is how we're now enabling kind of this middle use case that's shown here, and working with Oracle to really help migrate these on-premises data lakes from either a BDA or, you know, a custom Hadoop cluster on, say, some custom hardware into the Oracle Cloud. And then for completeness, I also kind of wanted to show this third use case where Oracle's really over this past year has been expanding into helping areas beyond just the Hadoop migration, still focusing on a lot of this unstructured data, but enabling the movement and migration of IoT data and file system data that's sitting out on your edge platforms or on-premises data centers, and move that to the cloud. And WANDisco really provides a solution that can efficiently handle kind of that volume and the performance requirements that's required with all of that IoT sensor data to the cloud. You know, so what makes these you know, data lake migrations challenging, right? I'd say it kind of, some of the main points are summarized right here on this slide, right? So one issue surely is volume, right? Typically these Hadoop data lakes are multi-petabytes in size, you know, and they continue to grow, right? And especially this unstructured data, it's growing at a rate of 55 to 65% a year, and now being driven even further with that growth of IoT that I talked about, IoT devices and data, which is actually estimated to become over 73 zettabytes of data by 2025. So enormous amounts of volume. But then in addition to volume, one of the biggest challenges in migrating these data lakes, you know, to the cloud is the ongoing activity that they're performing, right? It's not uncommon for, you know, these platforms to perform thousands of change events per second. You know, one of our customer examples is GoDaddy, right? And when we were helping them migrate their Hadoop data migration to the cloud, we measured their peak activity at over 100,000, you know, change events per second at peak. Really, and with an average load of around 20,000 per second over a 24-hour period. So very high volumes. They become mission critical, right? They can't be disrupted or taken down. So that makes the migration for, you know, many of the legacy tools to be very difficult or near impossible. And that's really where our solution can benefit. And then lastly, you know, adding to all the complexity is the data that often gets siloed across many multiple locations, right? And the question is, how can you migrate that high volume of actively changing data, you know, to the cloud? That's a very complex problem. And it's really what WANDisco was focused on solving. So how do we do it? And what kind of makes us different? That's really shown on this slide, right? So WANDisco is specifically designed to address this problem, right? The automated data migration that handles these key dimensions that I've been talking about, right? So any volume of data, and any amount of data change or additions, new ingest of data without requiring system downtime or business disruption, that being really one of the key things. So that enables you to really minimize the cost and the risk of these data migrations that are associated with some of these other products that I'll talk about, or other, maybe not even products, but methods that folks choose. So also, a key point here with WANDisco, organizations can actually begin with small migrations and then scale that to these largest data volumes without having to reinstall any new software packages. All the same solution, scales from the smallest all the way up to these largest data lakes. So typically kind of the other approaches that people take or that are available to them really only effectively handle really static data, or they become very custom solutions in order to handle all of this changing data. So, for the static data, probably the most common method that gets selected is to use, bulk transfer devices, or, physical devices that are intended for, this higher volume data copy. But again, with this approach, data gets copied onto the devices. The devices then get shipped by truck to the cloud service provider's data center. And then it's often, we're talking about many, many devices given the volume of data. And then, the data is copied off of those devices onto the cloud data center. And that process alone can take weeks or even longer. So the question is, what happens to your on-premises environment during this time? And in order for it, to ensure that data doesn't change and that you can finish in one step, the system would need to get brought down. But that's really not acceptable, as we've been talking about. I think a few folks have mentioned, for most organizations, they can't bring these production environments down, have to be up continuously. So, what the organizations do is they allow the changes to continue to happen, and it's up to the folks responsible for the data migration to figure out how to build out a solution to handle that changing data effectively. It's used, again, involves either multiple scans or building out some custom solutions themselves. When we're talking about Hadoop, also probably the next most common is some of these open source tools, right? Very often we see organizations trying to use DistCP, or distributed copy. It's a free open source tool that's provided with their Hadoop distribution. However, even DistCP, again, designed for intra or inter-cluster copies of data at a given point in time. So it also doesn't automatically handle changing data. Again, to enable the migration of that changing data, it needs to make multiple passes of the source data, and the organizations need to develop custom solutions to handle that. And that's really kind of this, third circle over here, further to the right, are purely custom in-house developed solutions or services-based projects where you get an SI to do it. And they may be leveraging also transfer devices in DistCP, but again, doing a bunch of custom code development on top of that to handle that changing data. Other approaches they may be doing are things like dual ingest strategy, where data is ingested simultaneously into the source as well as the target. All of these custom approaches really increase the development effort, the test, the maintenance effort, requires greater resources, either from the organization themselves or from the system integrator, thereby increasing the costs. They can impact application complexity and performance. And really, these things are not, data migrations are not the core competency of these organizations, right? So it also introduces opportunity costs if they're putting their own resources on these projects. And again, that's where WANDisco solution is very different. It automates this process. It enables the migration at lower costs and lower risk, because it is all automated and designed specifically for migrations. this is actually a reference architecture, which, is one of the reference architecture that Massimo discussed. He mentioned, how Oracle's been working with WANDisco on a reference architecture. So this is documented on the Oracle architecture site. If you go, I believe, into the solution guides, actually on the next slide, I do provide links to this document on our site as well as within Oracle's. So when you get the PDF, you'll get all of those links as well. So for the sake of time, I'm not going to talk through all of the details on this architecture, but just a few key items, right? So WANDisco itself, the software is installed on the edge node of your Hadoop cluster in this case, where we're migrating Hadoop data. Then performing the migration is as simple as kind of defining your target environments, right? The source is now automatically identified and all of that, because once you've installed it on the Hadoop cluster, it's identified the source configuration. You define the target environment where you want to move that data. You define your migration jobs. You specify what data that you want migrated, as well as what type of data you may want excluded. And you can also configure, various advanced configuration options, such as setting network bandwidth thresholds, path mappings, etc. So a lot of configuration capabilities. And then you can automatically start that migration. And then the rest is really automatic. WANDisco performs actually a single pass through that source data set. And migrates that data to OCI. If there's changes occurring, during that scan, it automatically picks up those changes as well and migrates those. And if you define the migration to be a live migration, it continuously gets notified of those changes, integrates with iNotify to get notified of those changes, so it automatically picks those up and replicates those to the target environment in near real time as well. All of that being done without bringing this, production system down, without any, system downtime or business disruption. Jamil actually made an interesting point too. He was talking about how some of the customers, don't necessarily know all of the applications that may be dependent on some of that data. So when they've migrated to the cloud, it becomes problematic for those applications. For this reason, many customers try to do a kind of a big bang, lift and shift type of approach, moving everything all at once. But that actually, rather than simplifying things, can further increase the complexity. With WANDisco, you can actually allow this hybrid environment to continue to run, live migrations continuing to occur. So you can continue to run the production environment, changes get replicated over, fully test the things on your data lake or on the new cloud instance, and ensure you're ready to turn things off or continue to run in a hybrid fashion for as long as you wish. Quickly on the data lakehouse, just a couple key points. So the data gets either migrated to Oracle data object storage or into a managed Hadoop ecosystem, something like a big data service, or and then optionally also the metadata can get migrated into Oracle's Metastore or data catalog. And once there, it becomes really immediately available to all of the Oracle analytics services to use. So that's really it very quickly, kind of went through that quickly, and we're just a little bit, I think, over time. So I don't know that we have any opportunity for Q&A, but I'll turn it over to Laura. This last slide, by the way, when you get it, you'll find links to, again, that white paper, the reference architecture, video demos that you can watch, as well as our documentation pages, so you have it all. And with that, Oracle, I'll turn it back